Good morning, everyone. Thank you for being with us here today for the Farm Foundation Forum, Opportunities for U.S. Agriculture in the Bio-Based Materials and Energy Economy. I'm Tim Brennan, Vice President of Programs and Strategic Impact here at Farm Foundation, and it's a pleasure to present today's forum. It's a beautiful sunny day here on our campus where we're being joined by a live audience of friends and neighbors. Delighted to have them here, and a special thank you to Farm Credit for their generous support in making this important conversation possible. I'm going to take just a few minutes to share a bit more about Farm Foundation. We're a 501c3 nonprofit, independent and nonpartisan organization. We're a trusted place where people from across food and agriculture can come together to build understanding. We'd like to think of ourselves as both a think tank and a do tank, turning great ideas into practical, real-world solutions for agriculture, and as a connector and catalyst, bringing diverse leaders together to help move agriculture forward. Specifically, we are an accelerator of practical solutions for agriculture, accelerating people and ideas into action. The three levers we use to accomplish this are policy, innovation, and education. Forums such as today are just one part of our extensive program of work, which is guided by our mission to build understanding and trust at the intersection of agriculture and society, and our vision to build a future for farmers, our community, and our world. And because turning that vision into action requires collaboration, we've created a space designed to help bring people together. Set on a historic farm, our campus in Libertyville, Illinois, is available for meetings, company retreats, and trainings tailored to your organization's needs, as well as an immersive program like our boot camps and ag and food labs. More than a venue, it's where innovation and education are brought together to drive progress. To learn more, scan the code that you see up on your screen or email us at connect@farmfoundation.org. Thank you again for being part of today's forum. And as a reminder, Farm Foundation is a nonprofit, and we rely on the generosity of people and partners like you to keep our programs thriving. Forums like this, where experts and stakeholders across agriculture share the latest insights and solutions, they're possible only because of that support. If you're inspired by what you hear today, we invite you to make a gift to help us continuing offering events like this to participants at no cost. Our team will post a secure link in the chat, and you can also visit farmfoundation.org and click the donate button on top of the page. We will also share updates about our work and what's happening across the agricultural sector on our social media pages. I encourage you to connect with us on platforms like LinkedIn and Facebook to stay up to date. Before I begin today's forum, there's just a few quick notes. If you have questions for our panelists, and I hope you have lots of them, please drop them in the Q&A section at the bottom of your screen, not the chat function. This forum is being recorded and will be posted on our website at farmfoundation.org, as well as on our YouTube channel, and we'll send out a link for that right after today's program. At the end of the forum, you'll also receive a link for a brief survey, and we'd really appreciate your feedback and time in completing it. So let's go ahead and get started on today's forum, which is going to be really fantastic. At a time when global events are exposing the fragility of energy and supply chains, agriculture is emerging as a powerful part of the solution. Plant-based innovation is expanding beyond food, powering fuels, materials, and manufacturing systems that can strengthen U.S. resilience and create new value for producers. Today's forum will explore the scientific and technical breakthroughs driving this shift, along with the policy and market conditions required to scale adoption. We'll also examine the infrastructure and investment needed to support the long-term growth in this evolving space. Throughout the session, we'll highlight how plant-based industrial applications can strengthen American agriculture, diversify revenue streams, and unlock new value across the energy, materials, and manufacturing systems. And to help us begin the conversation, I'm very pleased to introduce Sarah Glavin. Sarah is a distinguished authority in biotechnology and biomanufacturing. Currently, she's a visiting fellow at the Adlinger Center for Energy and Environment at Princeton University, as well as a founder and principal of Marathon Bio, where she advises startups focused on industrial biotech and national security. From 2023 to 25, Sarah served as Principal Assistant Director for Biotechnology and Biomanufacturing in the White House, Office of Science and Technology Policy. She also led the National Biotechnology and Biomanufacturing Initiative by establishing and chairing the National Bioeconomy Board. Sarah, it's great to have you with us, and go right ahead.
Thanks, Tim. It's an absolute pleasure to be here. I think probably there's folks on the call that I've interacted with in my previous roles, and I'm happy to reconnect. Something I should note before I start talking is that prior to my time at the Office of Science and Technology Policy, I was a research scientist for the Department of War for 17 years. So I come from a basic research background, very much bench scientist, discovery, innovation space. So that's what I'm going to talk about today to kick off the panel, just to give some high level overviews of the state of biotechnology. Next slide, please. So I like to think of biotechnology as a solution to many, many, many challenging global and societal problems, anything from health and well-being to next generation of chemicals and materials. And of course, our agricultural community is the foundation of these technologies, because when we're talking about using biotechnology as a tool for manufacturing, for biomanufacturing, it often starts with biomass feedstock. Before we keep going, I want to give the definition that I work from for biotechnology. And this is a definition that was established by the US government and put out by the National Institute of Standards and Technology. And you can find it at this link here. So this is the basis I use when I talk about biotechnology, is that it's technology that applies to or is enabled by life sciences, innovation, and development, and technology development. So I want to focus on that word, life sciences innovation, because biotechnology fundamentally has to do with how we are discovering and advancing the basic understanding of biological systems. And that's how we're going to get to that innovation piece and those next generation technologies. Next slide, please. That being said, and there's so much to say. Hopefully this comes out in the panel today. I only have a few minutes to kick off the meeting. I think that there's the current state of biotechnology, and then there's a future state. And a lot of times when we are describing the future promises of what biotechnology has to hold for society and to solve these problems, we are really imagining this future state. But there's a lot that we still have to do and understand to get to that future state. So I really think of biotechnology as in a very nascent phase. We have come to a massively greater understanding of biology, especially over the last 25 years. And it's been decades since we started using biology for technological purposes. But in the last 25 years, I would say since I was a undergraduate, I have seen massive advances in DNA sequencing, the sequencing of the human genome, the first plant genome. And now it's like you can just, from a laboratory perspective, isolate a microorganism from your favorite environmental sample and send off the mixture of the isolate and the mixture of microbes it came from, and spend hundreds of dollars to get DNA sequences back from all of those organisms. It's what they mean that really is still where we need a lot of technological advances. DNA synthesis, of course, is improving every day. And then you hear a lot about artificial intelligence and machine learning. Something I like to point out when I talk about the state of AI for biotechnology is that we've been using AI for a very long time in the basic research space. We just call it machine learning more than under the entire AI umbrella. And certainly the more recent development of generative models is changing the way that looks as well. I think that because of these fundamental understandings that we still have to work towards, biotechnology, sometimes you'll hear that products struggle to find entry into already established markets. But I don't think of that as of looking at biotech as like, well, we're at this place, we're not getting anything into market. We've kind of reached this pinnacle. We're never going to compete. I think it's just that we haven't yet gotten to the point where we can develop technologies and products to the point of like the new thing that biology is going to offer us. Um, I like to think about that in terms of computers, because if we think about where we started with computers 70 years ago, this room full of this one computer takes up this massive space. It's bigger than a human. Like we're never like, how is this how is this the latest and greatest technology? Whereas now it fits into the palm of our hands. Everybody uses um, computers every single day. But biology is much different. It's much more complicated because it's alive, right? It's we are biology. It's not something, a computer is something that humans built from the ground up. We put every little piece and part together. We understand what's going on in that system. Biology is very different. And to emphasize that point, please go to the next slide. So a lot of us probably, well, maybe it's not the case for me. I hope not, but I think of this because I have a ninth grader right now. Maybe folks on the call haven't really looked at a diagram of a cell since they were in high school. This is maybe what you would have seen, right? This is a plant cell, and it's showing what looks like complicated system, but maybe also could be pretty simple. There's a lot of empty space in there. There's organelles. We all know that cells from plants and animals have these different compartments within them, and it can be kind of complicated. But these cells are fairly decent size, about 100 microns, about the size of a human hair. And I think a lot of times people in their mind, this is something they can visualize when someone asks them if they think about a living cell as a factory. They can probably imagine the pieces and the bits and pieces and like, yeah, this is something we can understand. We can manipulate doing genetic engineering, and we can control it to some extent. But if you go to the next slide, this is really more what the level of complexity of a living cell looks like. So this is a rendering that's created from microscopic images of the smallest bacterium, or the simplest bacterium that we currently understand, to the extent that we can understand it. This cell is about 1,000 times smaller than a plant cell. So it could fit inside that plant cell, and it's massively complex. So there's some labeling that's done on this diagram, but if you look at this, and it's like a cross section through the cell, so it's peeling back the layers of the onion, really. Starting at the bottom is the outer portion of the cell. That middle portion is showing you some of the proteins in the cytoplasm, and then the windy yarn looking things, of course, are DNA, RNA, and other different cellular components. This is massively complex. And when we try to think about how these layers of the cell fit together and work and give us a functionality that's going to allow us to use these life science understandings towards biotechnological innovation, I think we have a long way to go. Next slide, please. So in the last couple of minutes, I just want to give a couple thoughts on how we get there. So I show this slide a lot when I talk because it's really important to understand, putting my former government hat on, where we are investing research dollars in the development and commercialization pipeline. So in the United States, primarily, we focus on using government dollars to fund that early stage lab scale research. But in the last maybe 5, 6, 7, 8 years, we as a government, I'm no longer in government, so I probably shouldn't use the royal we, are spending more on the pilot and scale up components. And I know some of my co-panelists are going to talk about that, so I'm not going to dwell on that here. But it's almost, the pie hasn't really gotten bigger. And so I think what I want to emphasize, the pie of spending hasn't really gotten bigger. So I think what I want to emphasize to all the stakeholders on the call is that to achieve that next generation of biotechnology innovation and discovery, and you can apply this to agricultural science, but it's true in general, is that we have to continue that basic fundamental research component. And we have to feed back information from the pilot and scale up and product commercialization into that basic research component so that we are supporting the type of information we need to bring us the best technology in the future. Next slide, please. I'm not going to say a lot about this. I'm just going to mention in a couple slides how I think that as a group of stakeholders this can be done. I'll start from the government perspective. I'm not going to read through this. I just want to point out that in government coordination efforts over the last 5 years, we emphasized the entire bioeconomy as one piece, as one initiative that needed to be coordinated, and it included all of these different categories. And I think at the foundation of that is research and development, which is why you see that there as a specific called out bullet, but that influences all the other pieces. Next slide, please. What we did during my time at the White House was form the National Bioeconomy Board. Greg Jaffe, who's also on the call, was part of that board from the USDA. And this coordinated all of the federal departments and agencies that are responsible for supporting basic research to come into one meeting and talk about how they were supporting these biotechnology initiatives. Right now before Congress, there is legislation put out by the National Security Commission for emerging biotechnology that would form a permanent biotechnology coordination office in the executive office of the president. And I think that that's something that if folks could support through the different channels that they have when they are speaking to government would be really important to include. Next slide, please. And my last slide is just to say, put an exclamation point on the fact that we have today's challenges that we're trying to address with biotechnology. There's a huge amount of promises for the future, and this has to be a feedback loop in how we address that through policy, whether it be coordination, whether it be incentives, and it involves everyone across the board to be a part of that to get the best solutions. Thank you.
So much there. That was terrific. Now I'm pleased to introduce our next panelist, Beth Connerty. Beth is the Regional Innovation Officer for the Illinois Fermentation and Agricultural Biomanufacturing Tech Hub and the Associate Director for the Business Development for the Integrated Bioprocessing Research Laboratory at the Great University of Illinois. Beth received her bachelor's in chemistry and a master's in bioenergy from the University of Illinois, and she received her PhD in energy science and engineering from the University of Tennessee and the Oak Ridge National Lab. In her current role, she leads efforts to build relationships with researchers and industry clients, as well as developing the biomanufacturing economy here in Central Illinois. So Beth, take it away.
Thanks, Tim. Thank you for that introduction. As Tim mentioned, I am Regional Innovation Officer for the Illinois Fermentation and Agriculture Biomanufacturing Tech Hub, which is quite a mouthful. So we are just going to call it IFAB, but I will point out that the name is just really descriptive of what we are doing. Next slide. So I'm going to talk a little bit about IFAB, and I'll maybe start by tying it into Sarah's talk as well. Sarah's talk about technology readiness level and the steps of maturation for a new biotechnology was really great, and she talked about some of the early fundamental research that's needed. IFAB is focusing a little bit further along on that technology maturation pipeline, and I'll explain a little bit more about how we're doing that. But if you are thinking about it as a continuum, we would step in after some of that fundamental research shows promise. So IFAB is a consortium of 36 members located here in Central Illinois. And we are trying to pull all of the pieces together to make the bioeconomy and biomanufacturing really work here in Central Illinois, and then supporting the economy more broadly. We're really focused on biomanufacturing because this offers an enormous potential to bring manufacturing domestically in the United States, and most of the input for biomanufacturing is agricultural commodities. And with Illinois being a leading producer of both corn and soybeans, I'm sitting here in central Illinois and certainly surrounded by agricultural commodities. We really think that there's no better place to build a biomanufacturing economy than here in Illinois. This also, I will just highlight that this offers an enormous potential for the economy as well. There are reports that vary greatly about how much of an impact it can have on the economy. But the one that we sort of use and reference is the potential for 200 billion additional dollars and a million additional jobs within the next, 10 to 15 years. And we're really focused on bringing as much of that to Illinois as possible. Next slide. So just for some base setting, Sarah did a great job of sharing about biotechnology and cell biology. And what we consider biomanufacturing is a very broad term. It is taking any type of plant material and turning it into any type of value added end product. And that could be a whole range of fuels, chemicals, ingredients. Next slide. So within biomanufacturing, again, that's a really broad term, and we are focused on a specific tool called precision fermentation. Fermentation itself is a technology that most people are familiar with. Fermentation is the technology that is used to make beer or wine or kombucha or soy sauce. But it is also the technology that is used to produce ethanol that we all use in our that is added to our gas and used in our fuel tanks. What makes precision fermentation, or the reason that I use the term precision fermentation, is just to say that these historical ways of using fermentation have evolved. Now we can use fermentation as a tool for a whole host of end products and markets. And a lot of the reason that we can do that is because of the fundamental cell biology and research that Sarah talked about in her talk. So just looking at this slide, it gives a really, really basic kind of high level overview of what precision fermentation is. We are taking a plant material typically. Again, so that's on one side of the inputs. Typically that is corn sugar or soy glycerol, but we can also use a whole range of agricultural feedstocks like energy cane or sugar cane, sorghum, sugar beets, a pretty broad range of agricultural commodities on the front end. And then interestingly, more recently, we can also use some gas fermentations as well, which is relevant to this audience because a lot of the gas that's being considered is kind of the effluent from an ethanol manufacturing facility. But any of those sugars, any of those carbons go into a tank, a fermentation tank, where those cells that Sarah showed a photo of are living and growing, and they're metabolizing the carbon that we're feeding it. And instead of producing ethanol or beer, now those cells are making chemicals that can be used in our food. So things like natural dyes to replace synthetic dyes, polymers that can be used for textiles to replace polyester or nylon, industrial chemicals or plastics. This technology is just offering a whole range of different end products that we can use now. Next slide. So with all that potential, why aren't we seeing this? Why isn't this just ubiquitous? Why aren't we manufacturing everything with fermentation? And unfortunately, it's a pretty straightforward reason. There are others, and fundamental research is important, but we really lack the infrastructure to help these technologies get to market. This shows the stepwise progression of a fermentation technology from the initial research lab all the way to a manufacturing line. And the fermentation tanks are unimportant, but my colleague Nicole likes to share an anecdote that if you think about the infrastructure, the lab, we're gonna translate this into baking cookies. So the lab is your home kitchen, and if you're baking cookies for your kids' school class, your kitchen is sufficient. But then if you want to bake cookies for your entire town, you're gonna need some larger equipment, some larger mixers, some larger ovens, and that's kind of the pilot stage. If you want to spread out and maybe distribute your cookies for your whole state, you're going to need some demonstration scale equipment, some larger equipment. And then, of course, you're going to need full manufacturing if you want your cookies to be, in every grocery store across the United States. And the same is true, the same type of infrastructure is needed to scale up a fermentation technology as well. And this problem, this middle step, is what IFAB is trying to solve to make sure more fermentation technologies can make it to market. Next slide. We were really fortunate that to achieve this goal, we have received funding both from the federal government and the state government and from some of our private partners as well. IFAB is a federally funded tech hub through the Department of Commerce's Economic Development Administration. And in July 2024, we were announced to receive just over $51 million for our hub. That's really great. Obviously, $51 million is helpful, but it is also sort of this stamp of approval or the spotlight saying that other people agree with us that Central Illinois can become a leader in the biomanufacturing economy over the next decade. Since Farm Foundation is based in Libertyville, I will also just flag that the state of Illinois has also been extremely supportive of biomanufacturing and this effort. We have received just over $31 million from the state to supplement our federal awards and to make this a reality. And so we're really excited about this. And if you can go to the next slide. I often get asked, all right, that's great. That's a lot of money. How is all that money being spent? And it is very much being spent on that problem that I was referencing earlier. It is about building the infrastructure. It is about building the physical tanks so that more companies and more technologies can use those tanks, can use that infrastructure. So if we go back to our cookie baking example, now there can be a whole bunch of different cookie bakers that all come in and use the same really large equipment to distribute their cookies all over the country. So not every single baker, not every single cookie needs to build out their own manufacturing facility. So we are building this for fermentation, and we are doing it in a stepwise manner. Enterprise Works supports really early stage startup companies. IBRL is the next scale. That is my home organization here at the University of Illinois Urbana-Champaign. We go up to 1,500 liters for fermentation. Our facility was also the one on that first slide, so you can see a photo of it and see what it looks like. Our industry partner Primient is building out the next scale of a fermentation tank at the 13,000 liter scale in Decatur, Illinois, just down the road from us. And then ADM, Archer Daniels Midland, has 80,000 liter tanks that they're bringing online to support these fermentation technologies. And what that's really creating is a lab to line or lab to manufacturing line ecosystem, all within a 51-mile radius here in central Illinois. Next slide. This is a bit of an eye chart, but it is just to show that I mentioned that we're a consortium of 36 partners, and that is really critical to our success. While the University of Illinois Urbana-Champaign is the lead for this and IBRL is leading this effort, we could not do this without the support of both our state and local governments. And our industry partners, those industry partners received part of the grant funding, but they have brought equal or more resources of their own to the table to make sure these projects get to completion. So this is really a labor of 36 groups, all kind of rowing in the same direction, saying we see the value in biomanufacturing for agriculture and for the central Illinois economy. So we would like to all work together to make sure that it reaches its full potential. Next slide. This is just my final slide to say that if anything about IFAB was interesting to you, we have an excellent communications manager, and she keeps our channels up to date, and we would love to connect with you further. And with that, I will hand it over. Thank you so much.
Thank you, Beth. That was great. Now I'm pleased to introduce James Glick. James is Executive Director of the Plant-Based Products Council, where he leads the organization's advocacy for a shift towards a more circular bioeconomy through greater adoption of renewable plant-based materials. He works to educate stakeholders on programs and policies that will support the growth of the plant-based products industry, helping to harness its environmental and economic potential to deliver a more sustainable future. He also serves as Senior Vice President of Advanced Bioproducts at the Corn Refiners Association, where he oversees the legislative and regulatory priorities related to the bioproduct policy. James is also a Farm Foundation Roundtable Fellow. So, James, on to you.
Tim, thank you. And exciting to kind of take the next link in this conversation we're having today and really focus on demand and market opportunity for the industry. And maybe as quick background, the Plant-Based Products Council, PBPC, is feedstock agnostic. And so while we might, most commonly see corn and soy as the most available feedstocks in North America, we have members that work with a whole range of feedstocks, some of which you see listed there. I think the other thing that's incredible about this industry is the diversity of the products that are possible through some of the technologies that Sarah and Beth talked about. And that ranges everything from everyday products, things like diapers and insulation, air filters that we have in our homes, to 3D printing filament. So some new technologies as well. If you're on the farm, biodegradable mulch films, lubricants, we see paints and sealants in the chemical industry, and then increasingly see interest from the national security and defense sector. So things like ammunition explosives, smoke grenades, corrosion inhibitors on pipelines and naval vessels. And so a whole range of diverse products are possible when looking at the plant-based products industry. And why is that? It's because of a range of benefits. So as we move to the next slide, you'll see that consumers understand that there's a whole host of attributes here, whether it's a direct impact on national security, global competitiveness, whether it's the economic perspective. USDA estimates the industry has about a $489 billion value to the U.S. economy, 4 million jobs. And generally, those are high-paying jobs, a diversity of jobs in rural communities. It's additional market opportunities for farmers. I think especially as we think about domestic markets today, that's something that is needed in the ag sector with the uncertainty on the trade challenges and some of the conflicts around the globe. Thinking back to USDA's BioPreferred program created 20 plus years ago, there has been a ton of innovation in this industry. It is not brand new, but it is constantly innovating and changing. And one of the constants through that window of time is these products have to deliver the same or improved functionality and attributes as something that might be conventionally available in the marketplace. And then, of course, there's the environmental benefits, whether that's related to soil improvement, whether it's air quality or addressing some of the pollution we see on the waterfront. And then finally, as the benefits that consumers think about is this idea of circularity, this increased awareness of showing kind of the links across the value chain, and at the end of the day, less waste in our systems. So, at the Plant-Based Products Council, we do a fair bit of consumer data and research. And as we turn to the next slide, we've got now 5 years of data. And so I think increasingly, see that there's great familiarity with bio-based products. Just over the last 5 years, that has increased from the 50% range to 71% in 2025. It's also been relatively stable over the last few years. So we're likely in a place of equilibrium. So clearly consumers are familiar with these products. They're also familiar with the materials that are used to make them, the agriculture feedstocks. Some of the data suggests that 70% of those surveyed are familiar with corn, bamboo, and hemp, and about 60% familiar with feedstocks like soybeans, sugarcane, and seaweed. So increasingly familiar with sort of that value chain as well. As we kind of then think about, on the next slide, as consumers are asked, what does plant-based mean? It's a wide range of positive attributes. That's healthy, or it's good, it's sustainable, it's better. But they also still think about, some of the food-specific terms, taste and edible. And so there's clearly a great deal of opportunity for consumer education and education throughout the entire value chain on what these products are and how they're made. Overall, this translates into consumer demand. And as we look at the next slide, some of the high-level data there suggests on the next slide that we've moved beyond sort of a niche status. 2/3 report using products made from bio-based materials monthly. Notably, these are often in things like household cleaners or paper products, personal care products. And those monthly use and purchases have increased, from 41% in 2020. So a pretty good kind of reportedly amount of growth there in that window of time. And then as you look forward and ask consumers, what percentage, or how many of them might be willing to buy these products in the next 3 months, reportedly 86% of those say that they have plans to do so. And that's been pretty stable since 2023. As we look at the next slide, and the key is really not so much what producers say they're going to do, but what do they actually do? And so, looking at those percentage of products that have been purchased, clearly what we see here is those types of products that have direct contact with consumer or food are the most common. Some of those same paper products, the food serviceware, straws, utensils, lotions, cosmetics, and some of the clothing that I think Beth mentioned from plant-based textiles. And so, they are making these purchases, but thinking about those important factors in doing so, consumers remain committed to quality and to environmental concerns, things like biodegradability, recyclability. So as we kind of move through the slide deck, this question of what products they purchased is important, but also the question of costs and the willingness to pay more is really key. We do see that, the effects of inflation and consumer cost concerns, having a big impact on how we all make purchasing decisions these days. And since 2021, as we've surveyed folks, they have been consistent in that the higher cost of purchase and the higher cost of production are the top reasons that they do not choose bio-based or plant-based materials. At the end of the day, is looking at this data, I think the takeaway is that 79% of consumers are willing to pay more, but the real question is how much more, and that's really a conversation about pennies and not dollars. Moving beyond sort of the kind of dollars and cents of the conversation, as we look at the next slide related to consumer perception, taking a value chain approach, I think, is important in this industry. And so thinking about how do consumers view other or links to that value chain for companies, whether that's on the manufacturing side or the kind of delivery to the consumer side, 81% of consumers are more supportive of companies that use plant-based or bio-based materials. And I think for any of those of us that are active in the kind of production agriculture sector, the data around this tie to the farm is really interesting, I think. There's a 63% increase in favorable views of farmers and the ag industry when a consumer understands they have a role in the ag feedstock production. And notably, that number for the ag and farm sector is highest among those, with a college education who are middle income earners who are making some of these purchasing decisions. So while there's great kind of consumer data on demand, there's good market opportunity here, that there are still challenges to growth. Some of those have been talked about. Beth touched on scalability and what they're doing at IFAB in Illinois on that front. The production costs, we're talking about new and retrofitted facilities in many cases. That has an expense to it. But these are also new and novel processes that will grow more efficient with time. There's importance of making sure that those consumers and those business-to-business kind of relationships, that there's strong confidence in kind of that value, and folks have a good understanding of what they're buying and what it means. With anything that's new and different, there are regulatory hurdles, be that permitting and energy common in manufacturing, be it things like treatment of biogenic CO2, is looking at that from an environmental perspective, or some of the specific chemical and other regulatory approvals. And then finally, for those products that have a real benefit on the end of life, whether that's recyclable or in many cases compostable or biodegradable, there's need for that infrastructure to really understand and benefit fully from the value of these types of products. One last kind of point on our consumer research, and I think it transfers kind of well into the conversation hopefully we'll have, and it's related to federal policy. I think there are a lot of challenges here. Some of those, the government can be helpful in solving. And I think it's encouraging that, about 73% of those consumers surveyed support federal investment and tax incentives related to the industry. We asked that question, actually broken down by political spectrum as well, as folks self-identify. And I think, for someone who worked on Capitol Hill for a while, I think it was, to me, encouraging to see that, from doesn't matter where you sit on the political spectrum, Republicans 75% supportive, Democrats 80% supportive, and independents 61% supportive of some of these investment in tax incentive policies. From where we sit at the Plant-Based Products Council, on that policy front, there are currently live conversations related to the Farm Bill, things like the Biomanufacturing and Jobs Act that helps provide some support for the strengthening of the USDA's biopreferred program, some important data collection for the industry, as well as key terminology that would provide confidence across that value chain. There's investment opportunity or kind of loan opportunity related to the Agriculture Biorefinery Innovation Act, the Ag Bio Act, and then also supportive of things in the tax space to help incentivize and address some of that biomanufacturing capacity that's needed in the U.S. So excited about a recent bill that was introduced in a bipartisan fashion, the Bio-Based Materials Investment and Production Act. So I look at the federal policy side. There is activity there. Sarah mentioned the National Security Commission's recommendations, and something I think we'll probably have a chance to visit more and more about. But I really think the federal policy piece plays into this market demand conversation, because the real opportunity, as we see it, the growing opportunity is really related to national security and American competitiveness. We've seen administrations committed to those issues as it relates to biotechnology since the early 2000s in different ways and forms. But it comes down to that key question of China and what other places in the world are doing. And so as we look at supply chain resiliency, critical minerals and inputs, as we look at kind of U.S.-based manufacture of some of the weapons and kind of defense-related supplies we talked about earlier, I think we're excited about kind of where this industry could go and where it's headed. Strong and encouraging numbers on the consumer side and growing opportunities. So with that, eager to hand off to the next speaker and look forward to a conversation.
Thank you so much, James. I'm now pleased to introduce our final panelist, Greg Jaffe. Greg is president of Jaffe Policy Consulting, which provides strategic advice on national and international policies involving agriculture and food, with specific expertise in sustainability, climate, bioeconomy, biotechnology, PFAS, pesticides, food safety, and food loss and waste. He recently worked as senior advisor for regulatory affairs in the USDA's Office of the Secretary and the USDA's Chief Regulatory Officer, where he managed a broad portfolio of policy issues, including the bioeconomy, biotechnology, and scientific research and development. Greg is a longtime collaborator with Farm Foundation, and we're delighted to include his expertise in this conversation. So, Greg, take it away.
Thank you very much, Tim, and thank you, Sarah, Beth, and James, for your presentations before mine. In the next few minutes, I'm really going to try to give you a perspective of what, sort of to answer the question, what is the federal government currently doing to support the bioeconomy, biomanufacturing, biotechnology, and bio-based products? Next slide. So as Tim said, I was in the federal government. I was, and as Sarah mentioned, I was the lead for USDA for bioeconomy for a couple of years, and I was also the representative on the National Bioeconomy Board. I currently have my own policy consulting business, and part of the mission of that is really to build up this industry, to help entities utilize biotech and biomanufacturing to turn above ground biomass into bio-based products. And so what I'm going to talk about, I could spend, when I was in the government, I could tell you all the details about all the programs. Now I'm going to tell you, because people have been asking me, sort of what is the Trump administration doing? Are they still supporting this area? So if you turn to the next slide, I'm going to, I couldn't go through all of the programs and all of the departments in the time that I have, but what I wanted to do is just point out some of the activities that are happening in the federal government and in this administration that shows that they are moving, they believe that the bioeconomy is important, that using biomass and biotechnology and biomanufacturing to make bio-based products is an important part for benefit to us for many reasons, as James said, for national security, for rural communities, for farmer income, and so forth. So the Trump administration in 2025 issued a number of executive orders. Two of those were around energy And one of those was around timber. And in all of those, they talked about, in the energy ones, they talked about the need for biofuels. And of course, biofuels is one of the products of biotechnology, biomanufacturing, and part of the bioeconomy. And timber, turning woody biomass into bio-based products, is also another one. Next slide. More recently, we've seen OSTP, the Office of, excuse me, the White House, the Office of Management and Budget, and OSTP talk about research priorities for 2027, and telling us that they would include this area in their priorities to scale supply chains, build scalable universal manufacturing, and support biological platforms in this area. Next slide. I wanted to start off with the U.S. Department of Agriculture, the agency that I know the best. And we have here a memo from Secretary Rowland at the end of 2025. This was a memo about the research priorities in the agency, both for external research, extramural research with NIFA, but also with ARS, the Agricultural Research Service. And you'll see here in the second of the research priorities, specific language talking about expanding the utilization of these commodities in novel bio-based products and bioenergy. And so this being an important thing that USDA wants to do in their research portfolio. Next slide. And in fact, most recently, a few months ago, went to the USDA ARS facility in Albany, California, which is the head of the West region. And they are one of the leaders in working on bio-based products. And took a tour of that facility, and you'll see some pictures here of bioplastics, rubber, natural rubber made from guaiuli plants. And the researchers here are working hand in hand with startups and companies to help build out bio-based products. Next slide. And then, of course, USDA has many programs that help try to build the infrastructure, help build those pilot facilities that uh, Beth talked about, that Sarah talked about, and help build, final production facilities in rural communities. And so I'm not going to go through all these programs, but the Rural Development Mission Area of USDA has a number of different programs that support companies that are trying to build bio-based products. And similarly, the Forest Service is doing a lot of work in terms of developing and doing pilots for products that are made from woody biomass. So I'll turn to the next slide. Next, I'll take a look at the Department of Energy. And again, I can't begin to just talk about all of the different programs the Department of Energy is doing to help not just biofuels, but bio-based chemicals and different kinds of bio feedstocks and so forth. So I just wanted to mention a couple of those. One was the Regional Biomass Resource Hub Initiative, and Department of Energy is spending a lot of resources to help with uh, developing purpose-grown energy crops, different crops than we might not necessarily think about, intermediate oilseed crops and so forth. And they've set up these regional hubs that are going to collect data over 7 years about these crops and their yields and their carbon impacts and so forth, which will be an excellent database for farmers to then grow these crops and then be utilized to be made into those bioenergy. Next slide. And similarly, when I was out in California, I went to the Department of Energy's Lawrence Berkeley National Laboratory, which again is all of the national labs work in this space, but this one in particular is a leader in this space. And they are again working with private industry, so in public-private partnerships to help private industry utilize different types of biomass, utilize fermentation capacity, different capabilities and downstream processing to develop bio-based products. And so it was really interesting to see they're doing everything from the genetics of the crops to figuring out how to break down that biomass to then how to downstream process to get final products that have yields high enough that they can be marketed. So a lot of work going on there. Next slide. More recently, the Department of Energy announced 26 Genesis mission challenges around AI, but I will point out that one of those is specifically about scaling the biotechnology revolution. So again, showing again the priority that is being placed on biotechnology in the federal government as a way to make us a continued leader in this space. And that's something that's still just started, and they're getting proposals in this area right now. Next slide. If we look at the Department of War, I know Sarah mentioned the Department of War, and Sarah's clearly more the expert than I am in the Department of War. But again, recently the Department of War identified 6 critical technology areas, and if you'll see, notice one of those is biomanufacturing. And so they are doing a lot, both in terms of research and development, pilot scale, and as well as infrastructure to try to build up our biomanufacturing capacity, both to help the war fighter, but also just to move bio-based products into the marketplace. Next slide. And they have a number of programs that are doing it. I can't mention all of them. I will mention BioMade, which is a program that is building both pilot scale capacity, similar to what Beth talked about in Minnesota and in Iowa and in California. They recently announced $21 million in projects with different companies and institutions to again build up the biomanufacturing sector. And DoD has issued a number of awards over the years to biomanufacturing, and we expect those to continue in the coming months and years. Next slide. So I'm going to turn a little bit now to more the regulatory side of the activities, regulatory and policy of the federal government. And of course, for many of you, I think when you think of bio-based products that you may have dealt with in your lives, one thinks about ethanol and biofuels. And so the EPA recently came out with its final renewable fuel standards for 2026 and 2027. And these were record numbers for biofuels, which I think pleased both ethanol, biofuels industry, but also farmers who are growing the crops that get turned into those biofuels. And so this showed, again, the importance of these bio-based products to our whole economy. Next slide. Similarly, in the big beautiful bill, Congress extended what we call the 45Z tax credit. This is the tax credit for clean fuels production credit. It had been first started in the Inflation Reduction Act under the Biden administration. And so here is the proposed rule issued by Treasury about how companies can take advantage of this. And so this is, I think, a very important step forward. James talked about the need for incentives or subsidies to help move this industry along, and this is clearly one of those. You'll see that I've highlighted the word USDA. USDA has put together a climate smart agricultural interim final rule, as well as a feedstock calculator that would talk about the carbon intensity of different kinds of crops and different kinds of practices. And that hopefully will get integrated into this 45Z tax credit. And so farmers' activities can help companies qualify for the tax credit. Next slide. And this is the Climate Smart Ag Interim Final Rule that was issued at the end of the Biden administration. Next slide, please. And the feedstock calculator that I mentioned, here's a picture from the website there. And again, this deals with 3 domestic feedstocks, corn, soybeans, and sorghum, with a number of different practices. But we are expecting a final rule in the next couple of months that may also add additional crops and additional practices that would get credit for their activities to reduce the carbon intensity of those feedstocks, which would then reduce the impact of the biofuels on the environment, providing the tax credit. Next slide. Finally, I also wanted to mention, I think James mentioned, there's a lot of different regulation for bio-based products, and they're regulated by a number of different agencies, and that this administration is looking to streamline those regulations in many cases to get many of those products to market quicker. I'll mention that FDA has their generally recognized as safe process for food ingredients that would be made. Beth talked about precision fermentation. We have a lot of food ingredients being made that way. That rule may be updated by FDA, and we're not sure where that's going to go, so people could look out for that. USDA regulates genetically engineered organisms, which would include things like biostimulants or nitrogen-fixing bacteria that might help farmers reduce their nitrogen and their fertilizer needs. USDA is at this stage revising its regulations for microbes, and we hope to see a more streamlined process that will help move those along. Uh, USDA and FDA regulate cell-cultivated meat, another bio-based product. Those regulations seem to be moving along fine with the industry, I think, having had 5 products that have been approved. The USDA regulates hemp. I think that was mentioned by James earlier, and I could go on with many other ones, but I wanted to just give a few select ones to show that there are a number of agencies that are working on regulating the safety of these different products. Next slide. Finally, I wanted to mention the Bio-Preferred program. This is one of my favorite programs. I think James mentioned it. It's run out of USDA, established in the 2002 Farm Bill. What it is a certification program that certifies the bio-based content of different products in the non-food space. It has both a federal procurement preference for those products, as well as a voluntary labeling program that can be used by manufacturers to put on their products that consumers like you and I would buy in the supermarket or in the hardware store. Next slide. And what's interesting about this is it's a fairly easy program for companies to get certified for. And then when they put on their label, they actually can put on the percentage of bio-based. So here's a product that has a 97% bio-based, but you could have a product 50%, you could have a product 100%. So it gives a lot of information to consumers and it allows for a lot of transparency. And hopefully that can turn out into the market demand that James and others say is out there for these products. Next slide. I recently asked the people at BioPreferred how the program was going. So this is the number of companies receiving certification for the federal procurement portion of that program. And you'll see there was a high in 2023, but we're still seeing a lot of companies that are coming into this space and getting certified. Next slide. And similarly, the number of products being certified in the last few years has really skyrocketed. And that again shows just the penetration of the market of these products that are coming out there. Next slide. So I finally wanted to just end with some legislation that's going on and some activities around trying to build up the bioeconomy. James mentioned some of these. One is the National Biotechnology Initiative Act, which would set up an office in the White House that would coordinate all the activities around biotechnology and bioeconomy for the federal government. I think Sarah mentioned that was something similar to this under the last administration. This would sort of put this into law that it would be done all the time. We have some other legislation. The list could go on here, but I mentioned the Bio-Based Materials Investment and Production Act. I think James mentioned that, the Renewable Chemicals Act. Both of these would set up tax incentive credits for products that were bio-based, and they would be certified based on the Bio-Preferred program. Next slide. And finally, I wanted to mention the Farm Bill. I think James mentioned this a little bit, but the Farm Bill, as many of you know, was passed the House. Was it last week? It feels like a long time ago already. And there's still a pathway to getting that passed and into law this year. And there are many provisions in that law that would benefit biotechnology, biomanufacturing, and the bioeconomy. I've listed some of them here. We have the 9003 program, which is the USDA program, guaranteed loan program for first of its kind biofuels and biochemicals infrastructure. That bio-preferred program that I mentioned is authorized under the Farm Bill, so it needs to be reauthorized. There's language there about USDA setting up a sustainable aviation fuel strategy. I think James mentioned the uniform bioproduct labeling. There are changes to make it easier for farmers to grow hemp. There are changes to EPA's oversight of plant biostimulants and certain plant incorporated protectants so that those will be able to get into the market quicker. And there's even legislation to establish a provision to establish within USDA an Office of Biotechnology Policy to coordinate within USDA all the activities in this area. So I'll end there and hope we can have some conversation and discussion about this and the other presentations. Thank you.
Thank you so much, Greg. That was terrific. Now it's time for the Q&A portion. Please submit your questions in the Q&A section and not the chat so that we can monitor those questions. We've gotten a few already, but go ahead and add your questions. I'll just start doling them out as they come in, but I'll start with a question that I had, which is, where is the first place that we'll see true large-scale adoption? Lots of you mentioned scale. Is it going to be fuels, materials, industrial inputs? And is there a certain place in the US that you feel adoption may be happening faster? So, any of you, I welcome any of you to take a bite at that.
I'll start, Tim, and others I'm sure will join in. I'm thinking of Beth in particular, but I think first that geography question, right? We do see, some interest in investment happening in kind of communities that are close to where our feedstocks are produced, right? So think about states like Illinois, Nebraska, Indiana. So that is, thinking about that transportation cost that could be avoided by having manufacturing capacity there. And the infrastructure exists. And so I think that's important to think about, not just where is manufacturing happening, but also the broader kind of infrastructure that comes around these types of facilities and is needed. As far as where in that mix of products, I think a lot of interest in the chemical space. As we think about our materials and some of our national security concerns, things that are currently, we rely on production overseas, perhaps. That was very real for many of us during the time of the pandemic and COVID. But I think it also, consumers are a lot more familiar with the need to look at manufacturing capacity here in the US on some of those products today that are imported. And so I think that chemical sector is one that I see is ripe for some opportunity.
I will maybe add on in reverse. So another area where we're seeing a lot of adoption pretty quickly is agricultural inputs. I think that this whole conversation is about building value for farms and farm communities and agriculture in general in the United States. And we know that input prices for farms have skyrocketed in the last few years. And a lot of it is being imported. A lot of fertilizers and pesticides and herbicides are being imported and have been subject to tariffs over the last couple of years. We have seen a huge amount of growth and demand for using biology and fermentation to create fertilizers, pesticides, herbicides, biostimulants for the agricultural community. One, because that's then full circle, right? Then it's agricultural commodities in and in input for farms on the outside. But also then it can be produced more on site, more distributed, more available, less transportation, less importing costs. So we've just seen an enormous amount of demand and growth for that. And then and maybe I would also just point out that this technology is not brand new. There are examples of really large scale adoption of biomanufacturing and fermentation. Amino acids, things like lysine, that is usually used as animal feed, is produced through fermentation. Citric acid, so anybody who has canned tomatoes or tomato sauce has used citric acid, and that is typically produced through fermentation technology. So there are really great examples of large scale adoption already in this industry. And that's not even touching, human health and pharmaceuticals where it's been used a lot. So again, I think it's leveraging that. And to the question of where, I think it will be important that those companies, and I am biased that I'm working with ADM and Primient here in Central Illinois, but Cargill and Ingredion and Tate and Lyle and Novonesis and IFF have also all used fermentation for their product portfolios for a really long time. And leveraging some of that know-how and some of that really deep infrastructure investment will probably point you to where it will be successful first.
I think.
I,
Okay.
I was going to, Beth sort of responded the way I was going to respond in some sense, that some of these markets are already established. I mentioned ethanol and biodiesel, which have been around for a long time, and we have huge capacity in those spaces. There are other products like bioplastics that have been developed and been on the market for a long time. They've not maybe reached the penetration we'd like to see, but they also are out there. So there are bio-based products that people use every day in their lives. Sometimes they don't know about them or they don't know of the option of that particular product in the supermarket or the marketplace, but they are there. And as to where they're going to be located, I mean, I always say biomass is local. A lot of biomass is heavy, and so you don't want to transport it very, very far, and you want to build the manufacturing near that biomass. So obviously the Midwest has a huge amount of biomass with corn and soybeans, but then we also have all kinds of other types of biomass like walnut shells and almonds in the San Joaquin Valley in California. We have huge amounts of woody biomass, hazardous fuel that's being underutilized in our national forests and other places. So I think where you're going to look for uh, development in these areas is where there are existing streams of biomass that are underutilized.
So, James, the next question was directed towards you, and it asks if there is a potential for expanded markets for bio-based products in the pharmaceutical industry. Do you have any thoughts or ideas about that?
Yeah, Tim, thanks, and good question to who submitted it. I'd say I think Sarah touched on the wide range of application of biosciences and sort of that range of industries and sectors and pharmaceuticals. To the questioner's point, ripe for opportunity here. We're mostly focused on the consumer product side and the materials side. But I think thinking about the pharma, that's another industry where we do have a number of those kind of materials are currently manufactured elsewhere in the world. And so good opportunity for looking at kind of bio-based solutions here closer to home and looking at onshoring some of those facilities potentially.
The next question asks, with concern over inflation and consumer dollars becoming ever stretched, is there a concern that there's a reduced opportunity for being able to charge the premium that we need for these new products to cover the cost that's been invested into their development? Will the average consumer who's paying more for fuel and food be open to paying a premium for something that has a more sustainable message to it? And anyone can grab that.
I think I'll at least start that question. Go ahead.
Sorry, James. Go ahead.
Go ahead, Sarah.
Well, James and Greg and I were both at the same meetings last week. We were down in Nebraska in the middle of the week talking with the Council on Competitiveness, and this question came up over and over and over again. So I'll just give my general takeaway and pass it over to James on the product side. But and it's something that I keep on top of my mind because I'm generally with the earlier development folks who like to say that there's this green premium that folks that will pay because when they just understand how much better these products are for the world, they'll pay it. But when you talk to the companies either at the startup level or at the corporate level that are building business plans, the resounding answer to that question is no, they will not pay that premium. So the products either have to become cost competitive, and this actually is something that needs to be considered at the R&D stage, or they need to have a performance advantage, but the performance advantage would have to be so massive to make up for that cost that someone would be paying it. It's probably not going to be a consumer. It might be, for example, the Department of War, because they need the super specialized material, but that's going to be a very limited market. James, over to you.
Yeah, Sarah, thanks. I think you touched on. I mean, it is that question of will folks pay, and while they indicate they're going to purchase these products in the next 3 months, when you ask that question about and look at the purchasing decisions, they're not paying a large premium. I think it's about 20% more is the most that you'll see most folks willing to pay, and I think the questioner mentioned other stresses, whether that's energy and fuel costs, et cetera, and those are also being felt, throughout the manufacturing value chain. And so I think to that question on kind of costs, these products have to be competitive, efficient, increasingly so. And to Sarah's point, that's not a conversation that happens at the consumer level. It's a conversation that happens throughout that kind of manufacturing chain.
So we have lost a tremendous amount of ground in trade to the production abilities of Brazil in particular, their ability to find more land and to grow 2 crops a year. Is there a threat in Brazil adopting these technologies and taking their crops and moving them through these bioeconomy systems rather than relying solely on trade Do you see do you see things happening? And maybe it's not just Brazil, maybe it's Argentina, maybe it's China, but is there anyone that's sort of ahead of us on this that we should be concerned about?
I think the answer to that is an absolute yes, Tim, and welcome my other panelists' thoughts. But I mean, that's sort of the crux of what the National Security Commission on Emerging Biotechnology that I think Sarah mentioned in her comments was looking at, right? Where does the US fall relative to the rest of the world? This innovation happens globally, to Beth's point, that the challenges on scale up means that folks might have a great idea in one of our laboratories, but then they move overseas to look at that pilot and demonstration scale, and then they manufacture there. So I think we have great competitive advantage as it comes to feedstock production in sort of our kind of transportation network. But this race for sort of the manufacturing capacity, I think, is one that is absolutely global. And looking, you mentioned Brazil. I think China is really a key part of that conversation as well.
Anybody else have anything they want to say about that? Greg, the next question is for you. Is there clarity for biogas producers that enables projects to realize the 45Z tax credits yet?
Um, unfortunately, I don't know the answer to that. I'd have to look back at the proposed rule. I didn't focus when I read it in the past on the biogas provisions of that. You can't have everything up in the top of in your head, and so the details matter with all this. So I can't answer that, and I apologize.
That's okay. So the next question comes from a roundtable fellow. Earlier this week, we had a book club event with author Michael Greenwald as our guest to discuss his book, We Are Eating the Earth. What does the panel think about his arguments based on the work of Tim Serkinger regarding land use and land that is not free? Biofuels are a major focus of this argument, as so it relates to this panel. Is anyone familiar with these works and would like to comment on that?
Mean, I could start. I've not read his book, but I think when I was at USDA, we had gotten a lot of the arguments about biofuels and whether biofuels was taking bringing more land into production or not. And I think, specifically with the renewable fuel standard. But if you look at the data from 2011, 2012, when the renewable fuel standard came into being, and today, you don't see any additional land into production in the United States for agriculture on the whole. The amount of land in production has not changed. The amount of land being used for soybeans and corn has not radically changed. What radically changed was the yield from each acre of that land. And so what we've seen is, 15, 16 billion gallons of biofuels being developed, being produced in the United States each year without the additional land being taken out being put into production. So I think that's, a strong piece of evidence that you can both have these crops be used for food and feed and also for fuel without changing that footprint of agriculture on the land. The other thing I might mention is, the USDA and Department of Energy did reports on biomass, and the DOE had this billion tons report. And it showed such a huge amount of existing biomass that's underutilized. I mentioned some of the woody biomass. We can talk about all different kinds of biomass that is underutilized. So I think that's a second thing that if we're using existing biomass, we're not taking new land into production to get products based on them. And the third thing I'd mention is, there's a lot of promising work being done on intermediate oilseed crops and using the land the way Brazil does with a second or third crop on that same piece of land and turning that into whether it's sustainable aviation fuel or specialty chemicals or something else. And so I think, in some ways, utilizing biomanufacturing and biotechnology to make bio-based products actually makes our agriculture more sustainable on a per acre basis, and makes farmers more sustainable and gives farmers and rural communities more additional income. So I'm not sure I understand. I agree that we have to be careful about taking putting more land into production in our country and around the world, and the negative impacts that may have on our environment. But I think that this area, there's a way to get a win-win out of it.
I think that's an interesting question, and obviously is a potential flashpoint, or has been in the past, from my understanding. I I would say uh, I wasn't aware of the deep history of this conversation until I started my fellowship at Princeton, because probably one of the reasons this question is getting asked is because Tim Sertinger has an affiliation with Princeton. Um, but, and I have met Tim and I've met Michael Grunwald, and I think kind of building off of what Greg just said, I think it's not it's not a conversation that should be ignored. The land use change conversation should include all stakeholders. And I don't know if that was always the case in the biofuels era. The other thing I would say in terms of opportunities for rural communities and farmers is that biofuels is one market. I don't want to minimize the importance of it, but I think as you've heard today about all the other different types of bioproducts that could be produced using agricultural feedstock, there are many, many untapped opportunities or underutilized opportunities to create products that the math is going to be very different for in terms of land use change, because you are not going to be immediately combusting the product as a fuel, right? So you might make a bioplastic or something where carbon is going to be utilized for a much longer period of time. So I think that also has to be part of the conversation going forward, is that full life cycle analysis, cradle to grave carbon utilization component. And that's all I'll add.
Great. We're getting lots of great questions from our in-house audience, so thanks to them for doing that. And we'll tackle their first question. And one is, can you talk a bit more about biostimulants and if the regulatory hurdles exist for broader adoption?
I guess I'm going to try to take that one. So,
Okay.
so I think there's a lot of potential with biostimulants, and biostimulants is a broad category that would include biofertilizers and some other bio-based uh, microorganisms that help increase plant growth and so forth. Um, I think it's a fascinating technology. I think there are both products on the market that are very beneficial to farmers and products that are being developed that could be extremely beneficial. And I think there was mention about, fertilizer costs being expensive and reducing fertilizer costs and so forth, but nitrogen fixing bacteria. The regulatory system for this is a little murky, to say the least. And one of the things in the Farm Bill would provide more clarity as to which of these products are regulated by EPA as pesticides and which ones aren't regulated by EPA as pesticides. And currently now, most of them are, so they can be regulated by both USDA and EPA. And that can be a long process and take a long time. And so there is, I think an attempt by stakeholders to streamline that process, as well as an attempt right now by the federal government internally to see what they can do to streamline that process for these products that I think will be very beneficial going forward. But the regulatory system right now for that uh, is a little clunky and not exactly, I think, I think the best way to describe it is we're putting square pegs into round holes. We're, regulating them as pesticides. They're not really pesticides, but they fit the definition of a pesticide by EPA, so they go into that bucket, but they don't have some of the characteristics of pesticides, and so it's not the best fit.
Greg's knowledge of the regulatory space is definitely deeper, but I'll maybe just share a little anecdotal experience about the companies and technologies that we've been working with. The spaces where we've seen the most growth for agricultural inputs, and I'm going to use a broader term than just biostimulants because I do think it's a lot of different inputs going onto crops. But I think that they're being helped by a lot of them are using already naturally occurring organisms or just finding a modality that hasn't been leveraged before. So a lot of the smaller companies that we're working with are using soil bacteria that is found naturally, and just growing it together in a different way, and then applying it to agricultural opportunities. So again, I think that in the long run, Greg spoke more specifically, but that is helping some of these technologies because it is not taking chemical-based formula and inserting it into a biological system, but it's finding better ways to leverage existing biological systems.
Beth, if I could stay with you, we've been seeing a lot of passion and excitement in the investment community here in
Mhm.
Illinois around fermentation. It seems to be one area of innovation that has really captured the imaginations here in the Prairie State. And I'm just wondering if you see that as continuing, if you've seen growth in those sorts of investments, or if you were concerned that the lack of investment might slow this down.
Um, can my answer be both?
Yes.
I agree that the state of Illinois has been extremely supportive and excited. We've talked to farmers and our local farm bureaus, and we talked at the state farm bureau meeting in December. And it does seem like our statewide community is understanding that if we invest now, that these are long-term markets for farmers and for agricultural commodities. And so there has been a lot of enthusiasm. We've seen that from the state government as well. The Department of Commerce and Economic Opportunity named biomanufacturing as one of its strategic growth areas in their 5-year development plan for the state of Illinois. So we have been really excited about that. But the reality is that these are capital intensive technologies and capital intensive projects. Part of the reason that IFAB is trying to work with ADM and Primient on this is because both of those companies have existed in Decatur, Illinois for over 120 years. That is 120 years of investment and growth and capital expenditure that can't just be recreated overnight by startup companies or by every single company wanting to get into this space. And so finding ways to either leverage existing assets or to bring new capital into this will be extremely critical for the industry's success. But I am grateful that Illinois is at least trying to find ways to make that work here in the state.
So I'll continue on with this kind of line of questioning with an audience question, Beth. It says U.S. expenditures on agricultural R&D have been flat or declining, and well behind the growing R&D research expenses of China and the EU. USDA's ARS staff were cut by 23% in 2025, and the Beltsville Research Facility is set to be closed. By no means is the only scientific government agencies experiencing major cuts. From your perspective, how do you think about your work and the trends in developing bio-based materials and energy? Is it concerning for the developing bio-based materials and energy to think of these cuts? And when and if these trends reverse, what opportunities do you think that might present themselves for future policymakers, researchers, and farmers? That was a long question, but
Yeah, that's a hefty question.
it is.
I mean, maybe to start, I am an employee at the University of Illinois, Urbana-Champaign. That is our land grant institution here in Illinois, and I am part of the College of ACES, which is our ag school, our land grant school. Yes, we have experienced firsthand the cuts to agricultural research in the last year and a half, and it has been detrimental. Our National Soybean Research Lab, I know, has been struggling. Our crop science department had a number of grants eliminated or opportunities maybe went dark. And it has been a problem. And I mean, I think that this ties into some of the questions before as well, right? If we are worried about land use, if we are worried about crop utilization and making our land use more efficient, then research in agriculture needs to continue. Fundamental research in agriculture needs to continue. The reason that yield has continued to improve for commodity crops, which means that we don't have to bring more land into farming, is because of agricultural research and crop breeding. And crop science research across the board. So I think that, the way that we're kind of skirting this problem right now is by posing this as an economic development opportunity, which seems to really have bipartisan support. And again, that's great. We have a way to continue moving these technologies forward, but they are at a more advanced technology readiness level. And again, if we want to continue to improve the economics and the efficiency of agriculture, fundamental research and scientific investment is critical. And if we don't do that, we will continue to fall behind other parts of the world. Sarah is at Princeton right now, and I would
Yeah, I mean, I
kick
don't
it
know
to
if
her.
there's definitely cuts, but I don't think it's fair to, I mean, Princeton has a big endowment and they will weather storms differently than large public universities, of which um, all of my degrees are from. So I definitely understand the difference there. But I think just commenting on R&D spending, basically, when I was at OSTP, one of the jobs of OSTP is to manage the federal R&D budget for research, right? And so what we were looking at, we did a data call for biotechnology and biomanufacturing across the federal government to understand the spending levels. And the number that came back for 2023 was $15 billion. $11 billion of that was for for Department of Health and Human Services. So that means that $4 billion was being spent by the rest of the government in biotechnology and biomanufacturing. $1 billion of that was from the defense budget for a special one-time spending spree that was happening in this space that was set to expire after a couple of years, right? So that means that we are roughly spending $4 to $5 billion a year in basic R&D spending across the entire federal government in biotechnology and biomanufacturing. To put that in perspective, when we were at the when we were in the Nebraska meeting last week, Council on Competitiveness, someone threw out a number of like, oh, well, we just need to put $30 billion in infrastructure spending from the federal government and incentives to accelerate this space. Well, who are you going to sell 6 times the amount of spending in biotechnology and biomanufacturing by the government? Who are you going to sell that to in Congress that's going to agree with that number? So I think the question kind of comes down to how much is enough at the R&D level, how much is enough across that commercial research development commercialization pipeline that government incentives can help to stimulate the growth of biotechnology in the United States. Where should it be spent? Like, what's the best way to spend it? I don't have an exact answer. It's like I said, the bioeconomy is this massive space with many, many different problems. So if we confine it to agricultural research, I'm not going to say a specific dollar amount, but what I would say is that I think we can do better if we have a more concerted effort to coordinate between people that generally do not, that underappreciate the research that's being done at agricultural programs in the Midwest and maybe sit on the coasts, that are creating certain types of technology that head into the health and medical services sectors versus the agricultural sectors, and really try to create better collaboration and cohesion among those communities. I'll give one example. As I sit on the scientific advisory board for the Innovative Genomics Institute at the University of California, Berkeley. They have tools that are so cutting edge using genome editing that I'm certain could benefit collaborations within Midwestern universities and research centers, that we could use federal dollars to help stimulate a better collaborative network between those institutions. That's my 2 cents, 5 cents.
Thank you, Sarah. So there was a comment from an audience member related to this that I think is interesting. And they say it's critical to pay attention to China's latest strategic announcements, such as their recent announcement of their 15th five-year plan, which prioritizes biomanufacturing, and the launch of their 5-year smart farming initiative, and particularly their activities in ISO, ICAO, and WRC that are all related to precision agriculture. I don't know if anybody has any further thoughts on that.
Tim, I might jump in. Actually, that's kind of dovetails with the previous question and conversation. I mean, I think the questioner mentioned the 25 announcement of the most recent 5-year plan. But I mean, looking back at 2006, I think it was the 11th five-year plan, where China prioritized investment in science and technology and specifically call out kind of biomedicine and the life sciences. I mean, 20 years later, we're seeing the sort of the outcome of some of those investments. I think there they had stated goals around investment in 2% of their GDP in research. They were looking at kind of decreasing the reliance on foreign technologies. And so I do think, I mean, to the questioner's point, countries like China, I mean, they're prioritizing a move away from this energy intensive manufacturing into recognition of some of these higher value kind of bio-based sectors. And so I think definitely something cause for concern in conversation.
A related comment, James, it says they'd like to highlight the need for investment, not just into startups or R&D, but the infrastructure needed to develop these products to commercialization scale faster. He said, James mentioned companies leaving the US to do this pilot scale research and not returning back to the US, and that is a huge loss for our industry.
I agree completely. I mean, I think the work that Beth and the team there and other places are doing is important, but it's not enough. And so a real challenge. I think Greg mentioned it, and I mentioned one of the recent tax bills introduced bipartisan. Would help incentivize kind of expanding manufacturing. Investment in manufacturing capacity is one of the options available. And so I think thinking about what policy tools exist to really focus on that pilot demonstration scale, but also larger capacity questions overall.
Right. I mean, I think of this, Tim, as to a large extent, I think that at some point, many of these bio-based products can compete with petroleum-based products and others when we get them to large enough scale and when they can, really be competitive in the marketplace. But getting them there is a huge infrastructure cost associated with that. And there has to be either some government support for that, whether that's tax incentives or subsidies. There's got to be the public, we've heard, won't pay a lot more for these products, but you've got to have some sort of pull to get it to that stage. And right now, that's where we're having the biggest trouble here. I think we have lots of great ideas, lots of proof of concept, things that could be in the marketplace tomorrow, but it's how do we get them at the scale that we need to get them at and at a price that we need to get them at.
There's an ag economist here in Chicago that frequently says if we can get the sustainable aviation fuel system up and running at scale, that we would crush and use every soybean in America next year. Do you agree with that assessment?
I think that if we can I mean, the goal in the Biden administration was to have 35 billion gallons of sustainable aviation fuel by 2050, and that would pretty much cover all domestic, the need for fuel for aviation. But I don't think anybody thought of that as solely coming from soybeans. There was a number of different feedstocks that would include woody biomass, intermediate oilseed crops, corn stover, a host of different ways to do that. And I think, I think it's not one, it's going to be a number of different technologies and a number of different feedstocks that are going to move us in that direction.
Sarah, you had mentioned Health and Human Services, and there's a question from the audience here related to that. It says, with the increased influence of Make America Healthy Again, otherwise known as MAHA, how do the panelists think this will impact further support or opposition to agricultural biotechnology development?
I mean, I think it could positively influence that. I don't know that that's true just because of the MAHA initiative. I think in general, it comes down to something again that the National Security Commission on Emerging Biotech has tried to foot stomp. I don't know the right way to talk about this other than increasing people's understanding, they call it bioliteracy, of what these products actually are and why they are healthier or better for the environment in a way that everyone can understand and appreciate. Some examples don't resonate with people when they hear the word sustainability. Sometimes they associate that more with certain political leanings. And I mean, that's unfortunate because I think we all care about the environment. But when you talk to people about things like microplastics, everybody cares about that. They don't want them in the environment. I think that um, yeah, sorry, I lost my train of thought. So, I know what I was going to say. Sorry. So something that really resonated with me, I've gotten in my different roles, I've gotten to visit some commercial scale biomanufacturing facilities that were using fermentation that Beth was describing to make products. And something that the operators really emphasized to me was that a lot of them had come from other types of manufacturing sectors, primarily the chemicals industry, and they were really happy to have jobs, manufacturing jobs, that did not expose them to toxic chemicals. So I think that that is another, from a workforce development perspective, that's something that also really resonated with getting more bioproducts commercialized.
Tim, I might just add that I think, just like the Maha movement has been an interesting mix of different people with different political backgrounds and different things, uh, different interests and different goals. Similarly, I think bio-based products can, in fact, meet and help achieve some of those goals. If you're somebody who's interested in reducing the amount of synthetic pesticides, well, bio-based pesticides and biostimulants and biofertilizers could do a real, could be very, very helpful in that case to do that. Again, if you're somebody who's interested in, additional protein in the food supply, there are a lot of food, precision fermentation that could produce, protein, for example. And, we can do things using less animal agriculture and so forth. So I think I don't think of it so much as the Maha movement, but thinking about what are some of the particular objectives or goals within that movement for change, and then are there tools available to achieve those? And I think if you look closely, you can see that there are many that biotechnology, biomanufacturing, and bio-based products can actually achieve some of those goals.
Uh, Somebody similarly said, asked whether the loss of public confidence, and I think they mean in institutions, government, and science, how that might be affecting our ability to grow this sector. So public distrust of, both technology, government regulation, environmental movements. Do you see those things as barriers?
I might say, kind of thinking about the last question as well, Tim. I mean, I think, as I remember thinking about this in the consumer research we've done, that transparency throughout the system is really important. I mean, I do think the understanding of science, the need for greater appreciation for what some of these end uses can do to improve our lives, better our lives, whatever the sort of objective might be. But I do think, it really does come down to is, that being very honest and transparent throughout that value chain. I think I'm thinking about the kind of data point on favorability for farmers and agriculture when folks understand some of these products, made from ag commodities. And so it's not a simple yes, no, or kind of a positive, negative. It's a complicated conversation, but I think that's because it's a value chain conversation, and it's one that has to be very, very transparent.
So I have a personal question based on our campus here in Illinois. We are planting industrial hemp for the first time. And Greg, you had mentioned in your presentation about hemp, new regulations for managing hemp production in the new Farm Bill. I'll tell you, it has been a challenge for us to get that up and running, even though we're only planting maybe a quarter or a half of an acre of it here on our farm. But Greg, do you have any more insights into that?
No, I mean, I think hemp is a real potential crop that really could play a big role in the bioeconomy. Hemp can produce a host of different products from it, including, bio-based building materials and so forth. It produces a lot of biomass very quickly. Um, I think, we have a long history of why weren't allowed to grow hemp in this country for a long time, and now it's grown, but under, as you said, pretty restrictive regulations. The Farm Bill would make some of that a little easier, but not as much as many of the stakeholders would like to do that. If you go to Europe, they're producing, they have hundreds of thousands of acres of hemp, and they utilize it in many different products. So I think it's an area where we are behind, but there's a real potential there, and I do think it can be a crop that farmers can grow and be of value to them. So uh, I'm glad that you're doing it. Maybe, maybe you guys can put together sort of some lessons learned, and then maybe we can present it to some of the policymakers as a good test case about what needs to be changed if we want to really move this crop forward, Tim.
And Beth, we're also growing with Canthus on our campus. We had some trouble getting that to germinate last year, so hopefully this year we'll have more luck. But another question from our audience here says, because consumers are more interested in paying cents and not dollars, utilizing existing commodity infrastructure will be important. How will traceability and verification happen so as not to increase the costs too much, either through mass balance or other verification methods to allow for scale and market success? Anyone like to tackle that one?
I might just say, this industry is one that has a lot of interest in it. And so folks are looking at a range of models to meet some of the consumers' interests in demand. But I think it comes down to that transparency to kind of what the product is, whether that's produced through something that's tested and certified like the biopreferred program with an ASTM test, or if it's something that's kind of done through a mass balance accounting system. There's a range of ways to kind of improve the quality of our products, how they're made, and what they're made from.
I
I
think
would just add to when I was at USDA, I mean, what I heard from companies who were coming into the biopreferred program was that it was a very inexpensive and simple way to be verified. The ASTM standard that they have is a simple test. It doesn't cost a lot of money. And so we were talking about, four figures or something like that to get what you needed to do here. And it's interesting to see that, Congress is picking up on that for some of these potential bills that they're doing. So I think, there are different ways to do it, but I agree with uh, James, that it needs to be transparent. Whatever you're doing needs to be transparent.
I think just to add in on that, because
We can't hear you anymore.
uh
Oh, oh, you're back. You're back.
great. So I think ever since I have been shifting away from government, I joined some of the ASTM subcommittees, and this comes up a lot. And I think one of the things that is important to have as part of this conversation in terms of verification and transparency is that whatever method you use is fully accountable. And so what I mean by that is, the gold standard for biopreferred is the ASTM method of understanding the biogenic component of a product. Some of the mass balance calculations, which I'm less familiar with, if you're not measuring the biogenic carbon, you're just doing it through a mathematical calculation. That might not account for, and coming back, like putting my scientist hat on and talking about this from a scientist perspective, things happen along the chain in terms of like, you can't just like dump in biogenic carbon into a chemical reaction with hydrocarbons that are derived from other sources and necessarily just assume they all get incorporated the same way as the product goes through formulation. So I think it's just something to keep in mind, because if someday consumer transparency requires the final product to actually be shown to be created from biogenic carbon and it has to be measured, but all along it was being reported to be a certain percentage of biogenic carbon just based on mathematical calculations, that's not going to fly with consumers, right? Then we've just completely lost another whole sector of consumers that already had this doubt and mistrust potentially from what they were being told. And the reason I bring that up is because I think some of the legislation that's being introduced into Congress right now tries to change that language from what the actual standard of measure is. So maybe for this stakeholder group, it's important just to make sure you're educated on what those changes mean.
One question from the audience is the current conflict and associated impact on global fossil fuel supply chains has very likely increased interest in renewables, particularly for energy dependent entities like China, as we talked about earlier. Are we seeing grain strategically evolving from being just a commodity and into an energy asset? Is that now or is that 10 years from now?
I mean, I'll maybe just say that we have seen that this comes and goes in waves, right? Every time oil prices rise, then you are looking, or the U.S. is looking more at our commodities and how that can be energy. It is, yeah, it's not the first time. Biofuels were huge in the early 2000s in particular, as oil prices were high. The problem is that then oil prices drop again and everybody forgets about the bio alternative. And so it's not like flipping a light switch. You can't go from a petroleum heavy energy sector to a bio heavy energy sector in the amount of time this Middle East conflict has taken place thus far. And if we don't, and this is going back to maybe the soapbox I was on earlier, but if we don't continue the momentum, if we don't continue to invest, then inevitably when there is the next oil crisis at whatever scale or whatever amount, we won't have the pieces in place to swap easily. And I think the whole national security angle of this, of bioprocessing, biomanufacturing, of looking at our commodities as an energy source is a long game. And that if we want a true national security option around energy and as petroleum alternatives, that needs to continue despite no matter what a barrel of oil costs that day.
I think
So
this
let's
is also a place, though, where and I'll leave it to the policy experts to call out the specific pieces of legislation, but it's an opportunity to also consider where other products that petroleum enters the value chain, how that can be used to diversify where ag inputs are going. And I mean, I see that the new like renewable chemicals act that's being introduced, that's just one of many forms of these legislation, are going to try to incentivize production of those molecules. But if as a sector, ag stakeholders continue to focus only on fuels, then and revising that legislation, then we're not going to push through these other key pieces of legislation that will then accelerate product diversification. And I think this does align with what Beth is saying. But I mean, that's really important to do now, so that in 20 years from now, we're not going, well, why did we never create a tax incentive for biochemicals? We just did it for fuels. It doesn't make a lot of sense.
Sarah, I might just quickly echo kind of what you said, because as the question was raised and Beth responded, I was thinking this was really a 20 years ago conversation on the fuel side, thinking about sort of the kind of RFS implementation there. And then just contemplate, I mean, other countries in the world are able to turn, from one to the other feedstock input a lot more rapidly than we can in the US. And so I think to your point, now is the opportunity to think beyond just the fuel sector and what policy is needed to make sure that there's broader opportunity there.
Well, why don't we do a couple of quick fire rounds before we wrap up? And the first question for each of you is, what's the biggest bottleneck right now? Feedstock supply, processing infrastructure, capital, market demand, or something else? And I'm just going to go on my screen here. And Sarah, that means you go first.
Sorry, Tim, can you just repeat that one more time?
Sure. What's the biggest bottleneck right now? Is it feedstock supply, processing infrastructure, capital, or market demand, or something else?
I mean, they're all somewhat of a bottleneck, but something I'll bring up. I held a workshop last week at Princeton. Actually, it was 2 weeks ago now, to explore some of the bottlenecks in three specific areas: feedstock, process technology, and power and energy. And there were many outcomes. I will be creating a report on this workshop, but one thing that stuck with me was that feedstock, like utilizing these alternative agricultural feedstocks that Greg has mentioned and James has mentioned and others have mentioned, requires actually investment in scale up infrastructure just to process feedstock. We're always talking about fermentation scale up infrastructure. We need to also focus on the scale up research and development for utilizing these alternative feedstocks. That's what's on top of my mind.
Perfect. Beth, you are next.
Yeah, and maybe that is why IFAB is so invested in corn right now because it is the feedstock that is available immediately. It is what we have immediately. But I mean, for me, I have sort of bet my career here on it really focusing on the manufacturing infrastructure and that being one of the biggest bottlenecks right now.
James?
Yeah, and I mean, I think both of those areas have great importance, but I think really kind of going back down to the consumer, the market that I talked about, is some certainty on the demand front. Some guarantee of kind of what that demand will look like. Cost, price play into that. So I think that is the biggest bottleneck there is someone who's, our world is dynamic, it changes quickly, and increasingly at a rapid pace. And so some certainty on demand, I think would be really valuable in driving investment across the value chain.
Greg?
It's not my area of expertise. Mine's in the policy and other areas. But when I talk to companies, I keep hearing from companies who are going either to Brazil or to Europe to produce their products because they don't have the infrastructure. Either we don't have an existing infrastructure that they can use here, or it costs too much money to build their own infrastructure and they can't get the capital to do it. And so to me, that's a lost opportunity.
Thank you. So last question would be if you had to place a bet on a long-term view of a technology or pathway that will matter in 10 years, what would it be? And it looks like Beth, you're the first up for that one.
Oh boy, really put on the spot as the first one there. I mean, I would bet on biomanufacturing in general. I think that this is going to continue to have momentum and have legs. I think in the near term, I would prioritize or I would think about things that need smaller volumes immediately, where we can have an impact in the market without having to completely replicate the ethanol industry or something. So things like small formulation percentages for food ingredients. Again, I really am excited about the growth in agricultural inputs. And higher value end products. I think that that's where it's going to really see success in the shorter time period.
Okay. Greg?
Um, I mean, I can't disagree with Beth. I agree that biomanufacturing generally, I think, is, where to go. But I would also say I think the genetically engineered microbes, the products that can be made to fix nitrogen and reduce fertilizer input and do plant growth, I think those are um, on the cutting edge of something that can really have broad impact. And what I like about those is they're really scale neutral. They could help farmers in the United States who are producing, have farms with thousands of acres, but it also could help farmers in Africa and other places. So I see those as really potentially being able to change the way farming occurs.
James?
I think there's probably hopefully a range across the spectrum that will be very successful 10 years from now. But as I think about it, it's looking at some of the data on what consumers are demanding. It's the personal care products, right? I mean, thinking about cosmetics, et cetera, chemical based, thinking about, those drop-in alternatives, probably where there's some near-term window. And again, likely a little bit smaller volumes for some of those products.
And Sarah?
Yeah, I would Greg kind of stole mine. I'm a microbe person. I think microbial communities are going to be key. We're just beginning to understand how to leverage them. I also think the other thing I would look out for that's maybe slightly different is plants as factories themselves. So how can we best leverage plants to be the producers? So this takes microbes out of the picture in some ways in terms of fermentation. But I think as we improve dramatically our ability to genetically modify plants over the coming decades with all the new tools we have, then that's going to be a big area that we haven't yet fully explored.
Terrific. Well, thank you all so much, Sarah, Beth, James, Greg. This was a terrific discussion. Really appreciate everybody in the audience, both online and here at the farm, for joining us and submitting some really terrific questions. We appreciate everything, and we'd love to hear your feedback. So please take a moment to share your comments about today's session in the survey that you'll see at the conclusion of this. You can also use that QR code that you see right there in front of you. And again, I'll invite you, if you enjoyed today's session and want to support the work of Farm Foundation, please consider making a donation, and we would certainly appreciate that. Thank you all once again for joining us today, and that will conclude our forum.